student of class 11th. Once again we are here with a new video, and in this video we are going to cover about topic conical pendulum. So what is conical pendulum? First we understand what is conical pendulum. A conical pendulum is a simple pendulum which is given a motion so that bob describes a horizontal circle and string describes a cone. Means the bob will move in a horizontal circle and a string with which the bob is attached will make a cone. So this type of motion when the simple pendulum is there, it is called conical pendulum. So again, conical pendulum is a pendulum which is given a motion so that bob describes a horizontal circle and the string describes a cone. This is known as conical pendulum. As you see in the diagram, the bob which is moving in a horizontal circle and the string, the thread by which the bob is attached, is making a cone. Here also a conical pendulum is a simple pendulum which is given such a motion that the bob describes a horizontal circle and string describes a cone. This type of motion of a cone is known as conical pendulum. Now, how to find the time period of conical pendulum we will see in this video. If you see the first diagram, the pendulum is attached from a support and at certain time it is moving on a horizontal circle, it making angle theta with the vertical, and the mass of the bob is m, tension is provided in the string is T during the horizontal circle, and if you resolve the T component T into two component, the vertical component is T cos theta and the horizontal component is T sin theta. Now if you see the diagram, so you know very well that why we are taking the theta T cos theta, because if you make a parallel line with H, then you see that the theta is alternate angle, so T can be resolved into two components, T cos theta and T sin theta. So V is the linear velocity of the bob, H is the height, T is the tension in the string, theta is the semi-vertical angle of the cone, small g is the acceleration due to gravity, and L is the length of the string. So this is the diagram which shows that what are the components of the tension we are taking here. So T is resolved into two components, vertical T cos theta and horizontal T sin theta, and from this figure it is very clear that mg is balanced by T cos theta, and the T sin theta, which is directed toward the center of the horizontal circle, is providing centripetal force to the bob to move in a horizontal circle. So the force acting on the bob at the position A is first weight of the bob acting vertically downward, the weight mg which is acting downward, and the second tension T acting along the string. So two forces are acting on the bob. One is weight of the bob which is acting downward, and other is tension T which is acting along the string. The tension T in the string can be resolved or can be taken into two component, T cos theta vertically upward. This force is balanced by the weight of the bob, that is in the figure you can see T is balanced, T cos theta balances the weight, or we can say T cos theta is equal to mg. This is the first equation. The second, T sin theta acting along the radius of the circle and directed towards the center of the circle. So T sin theta provides the necessary centripetal force for the circular motion of the bob, and therefore we can say that T sin theta is equal to mv square by r. Mv square by r is the magnitude of centripetal force. So T sin theta is mv square by r. This is the second equation, and the first equation we had find earlier, T cos theta is equal to mg. So we can divide 2 by 1. So we will get tan theta is equal to v square upon rg. Sin upon cos is tan, If you solve in your copy, then you will get tan theta is equal to v square upon rho. This is the third equation. From this, what is v? V is under root rg tan theta. This is the linear velocity. This equation gives the speed of the bob, and the relation between linear velocity and angular velocity is v is equal to r omega. V is equal to r omega, where omega is the angular velocity and v is the linear velocity. So putting the value of r omega in the place of v, so r omega is equal to under root rg tan theta. Now square both sides, you will get r square omega square is equal to rg tan theta, and from the diagram it is very clear that what is tan theta. Tan theta is equal to r upon h. R is the radius of the circle and h is the vertical height. So tan theta is equal to r by h. So in place of tan theta you put r by h, so you will get r square omega square is equal to rg r upon h, or omega square is equal to g by h, or omega is equal to under root g by h. This is the value of angular velocity in the term of acceleration due to gravity and height of the pendulum, that is omega is equal to under root g by h. Now to find the time period, since time is equal to distance upon speed, so distance covered by the bob is 2 pi r and the speed is v, so we can write t is equal to 2 pi r upon v, and we have to find the value of v. V is equal to rg tan theta. To put the value of v in the equation, t is equal to 2 pi r upon v, so t is equal to 2 pi r upon under root rg tan theta. Now if you solve and put the value of sin theta, r by l, you will get t is equal to 2 pi under root l cos theta upon g. So this is the time period, t is equal to 2 pi under root l cos theta upon g. And put the value of cos theta is equal to h by l. So t is equal to 2 pi l cos theta upon g. In place of cos theta, put the value h by l. So the relation is t is equal to 2 pi under root h upon g. This is the time period in the term of height of the pendulum and acceleration due to gravity, and previously what we had seen that it is in the term of angular velocity, in the term of acceleration due to gravity and theta. So this is the time period of simple pendulum, or we can say conical pendulum. So the time period of simple pendulum depends on the following factors. One is length of the pendulum. The second is angle of the inclination to the vertical. What is the angle made by the vertical? And the third is acceleration due to gravity at the given place. These are the three factors on which the time period of conical pendulum depends, and it is independent of mass of the bob, because if you see in the relation, we had not taken m anywhere, so the relation for time period is independent of the mass of the bob, or we can say that time period is independent of mass of the bob. So this is all about the conical pendulum. This is the part of circular motion. Derive this relation on a copy, solve the numerical of this on this topic from your NCERT, and if you have any problem you can find and call me on my number. Till